Hello friends, welcome to my YouTube channel. Today we are going to see interfacing of ADC to 8051 microcontroller. As you all know, analog to digital converters are the most widely used devices for data acquisition. Digital computers use only binary values, that is discrete values 0 and 1. But in the physical world, everything is analog, that is continuous. Temperature, light, humidity, and velocity are a few examples of physical quantities that we deal with every day. A physical quantity is converted to electrical signal, that is voltage or current, using a device called a transducer. Transducers are also referred to as sensors. Sensors for temperature, velocity, pressure, light, and many other natural quantities produce an output that is voltage or current. Therefore, we need an analog to digital converter to translate the analog signals to digital numbers so that the microcontroller can read and process them. So now we'll see some basic functions of ADC IC. So here is the pinout diagram of ADC 0808 or 0809. So here you can see there are 8 analog inputs or 8 analog input channels IN0 to IN7. So these are analog input channel, means by using these channels you can give analog input to ADC. You can select any one of the channel of 8 channels. Next there is a ground pin and a VCC pin. This clock pin is used to provide external clock pulse to ADC. So speed of conversion is determined by the frequency of clock. Next you can see these D0 to D7 pins are the 8 digital output pins, meaning these D0 to D7 pins will give you 8-bit digital data converted from your input analog data or analog signal. Next there is a EOC pin. This EOC pin stands for end of conversion. When ADC finishes conversion of analog data to digital, this pin gives high to low pulse. Means EOC gives high to low pulse, meaning that conversion of analog to digital data is done. Next is OE. This is output enable pin. When OE is high, ADC sends converted digital data on D0 to D7 pins. Means OE sends converted digital data to these D0 to D7 output pins. Next are these 3 pins A, B and C. These 3 pins are selected or are used to select analog input channel IN0 to IN7. So we'll see next how to select these channels. Next is ALE pin. So ALE is address latch enable and it is used to activate the address decided by pins A, B and C. Next pin is SC. This is start of conversion. So when you set SC high, ADC starts conversion of analog input to 8-bit digital data. Next 2 pins are V reference positive and negative. So this V reference positive and negative pins determines the step size of conversion. As you all know, analog to digital conversion uses sampling and it requires a step size. So these two pins determine step size of conversion. So here is the some basic functions we already discussed about pins of ADC, analog input channels D0 to D7, that is data output channels, our digital output digital outputs, start of conversion, end of conversion, output enable, ALE and ABC. So next we are going to see how these pins A, B and C are going to select one channel from IN 0 to IN 7, that is analog input channels. So here is how A, B and C selects IN 0 to IN 7 analog input channels. So when you give all 1 to A, B and C, it selects input channel 7, or depending upon 0 and 1 to given to A, B and C, you can see selecting a different channel. Again, clock is provided to determine the speed of conversion. Here you can see V reference positive and V reference negative. It decides the step size of conversion. For example, if V reference negative is grounded, that is it is given a ground voltage or 0 volts, and V reference positive is given plus 5 volts, then step size will be 19.53 millivolts. And if V reference negative is grounded and V reference positive is plus 2.56 volts, then step size will be 10 millivolts. Step size will be 10 millivolts. Next we'll see interfacing of ADC with 8051. So this figure gives the overview of interfacing 8051 to ADC. So this is your 8051 IC and this is your ADC. So you can see different port pins are assigned to different pins of ADC. So first, port P2.5 is assigned to OE, port 2.6 is assigned to SC, port 1.0 to port 1.7 is assigned to digital output pins of ADC. Port 2.4 is given to ALE, port 2.7 is connected to EOC. As you can see, these A, B, C pins are connected to port 2.0 to port 2.2. Here you can see V reference negative is grounded, clock pulse is given, and channel 1 IN1 is selected to give analog voltage. So using this port you can give analog voltage to channel 1. Here you can see V reference positive is 2.56 volts, meaning that step size of conversion will be 10 millivolts. Again VCC is given as a 5 volts. So next we'll see the basic program for analog to digital conversion. So first we'll assign port pins to different names. So port 2.4 is assigned to ALE, port 2.5 is assigned to OE, port 2.6 is assigned to SC, port 2.7 is assigned to EOC. Address A, B, C are assigned to port 2.0 to port 2.2. Now we equate port 1 to my data, meaning that whenever we are going to use port 1 in the following program, we will use or we will name it as a my data. Again we'll start from 0h, 0 program memory location, and first we'll move FFH to my data, that is port P1, meaning that moving FFH to P1, it will make port P1 as a input port. The next part is, first we'll set EOC, meaning that while setting EOC, EOC will give high to low pulse when conversion is done. Next we'll clear ALE, SC and OE. Again we'll consider this loop. In the back loop, first we'll clear address B and C and we'll set address A, meaning that IN1, that is channel 1, is selected. Then we'll call some short delay. Then we'll set ALE, that will activate the address decided by pin A, B and C, that is IN1. Then we'll call some delay. Then we'll set SC. Setting SC, that is making SC a high pin, the ADC will start conversion of analog data to digital data. Again we'll call some delay. After that we'll clear ALE and SC pins. Next, in this loop here, it will check EOC either low or high. While EOC is high or it is not it is set, program control will stay inside this loop only, here only. As soon as EOC is set low, when ADC finishes conversion, end of conversion, the program control will jump from this loop to next instruction. Here you set OE again, that is output enable, meaning that this will send the converted data to digital output pins D0 to D7. Then we will call some delay. So whatever output data we have given to D0 to D7 pins, it will received by port 1 pins, as port 1 is connected to D0 to D7 pins, and will move that converted data to accumulator. Next we will clear OE, that is output enable pin, and we will call conversion function. This conversion function will convert hexadecimal data to ASCII numbers. Next we will call data display. This data display function is used to display the converted data to the display devices. Next again we will call or jump to back. So this back function is here. So again this ADC will start to convert new data. So this ADC will continuously convert analog data to digital data. So I hope you all understand the functions of ADC and programming part. If you have any doubts, then you can email me or you can call me. So thank you very much and goodbye. As you all know the effects of corona worldwide, I would suggest you to stay home, and I hope you stay safe. Thank you and goodbye.